Welcome to the class. Last class we discussed about two stable states. One is octet state, next is duplet state, and 2n square that describe the distribution of electron in the shell of an atom or maximum electron that can hold in each shell. And also we learned about first electrons contains maximum 2 electrons, second cell contains maximum 8 electrons, and it is all due to 2n square rule. And the outermost cell should not contains more than 8 electrons, but it can contains 1, 2, 3 to till 8 number of electrons, but it cannot hold more than 8 electrons. Now today's focus is about valency. Today's focus is about valency. Combining capacity of element with other elements to form compound is called valency. Generally, you can say valency the combining capacity of an element. And the second one, on what factor does valency depends? It means that it depends upon the outermost electron. That's why we call outermost electron as an valence electrons too. And if the valence is 0, it means that the elements are stable, or the atom is stable, so it doesn't take part in chemical reactions. Otherwise, if valence is not 0, they take part in the chemical reaction. And here are the list of elements and their corresponding valency, which I am going to discuss. Okay. Hydrogen outermost electron is 1, that's why its valence is also 1. Helium outermost electron is 2. So generally helium, I have told you in duplet state, generally hydrogen, helium, lithium, beryllium, they follow the and boron also, they follow the duplet states. That's why its outermost electron has 2 electrons, so it is stable by using by duplet state. So it is stable one, so that's why valence is 0. In other case, except for octet state, and just we have to subtract with the 1, with 8. Beryllium outermost electron is 2, so its valence is also 2. Boron outermost electron 3, its valence is 3. Carbon outermost electron is 4, its valence is also 4. Now for nitrogen, outermost electron is 5, so valence cannot be more than 5. Valence is just 0, 1, 2, 3, 4. So subtract with 8. Why so we are subtracting with 8 is because this nitrogen follows the octet state, so 8 minus 5, that is 3. Similarly, oxygen, its outermost electron is 6, so 8 minus 6, we are getting 2, so its valence is 2. Fluorine's outermost electron, it contains 7 electrons, so 8 minus 7, that is 1. And neon outermost, it contains 8 electrons, that's why 8 minus 8, 0. Now main thing you should learn here is here case the two scenario. One, those who are having the outermost electron 1, 2, 3, 4, they generally lose electrons and they follow the stable states. And those who has outermost electrons more than 5, they generally gain electrons. So it means that if lithium lose 1 electron, it is stable. Beryllium lose 2 electrons, these 2 electrons, it is stable. If boron lose 3 electrons, it is stable by duplet state. If carbon, generally in case of carbon we can't say because it might share the electrons, but the rough idea is the same. In case of nitrogen, it's 5, it should gain 3 electrons. So if it gains 3 electrons, then the outermost electron should be 8, so it is stable now. So nitrogen is reactive. Why nitrogen is reactive? Because it has to gain 3 electrons to be stable states, and every element's atoms tries to be stable. Oxygen outermost 6, so it needs 2 electrons to follow the octet states. That's why its valence is 2, because it needs 2 electrons. Those who gain electrons should be kept at the back side, they are negative, and those which gain electrons should be kept at the back side, and which lose electrons, because these elements are losing electrons, so they should be at the kept first side while making the molecular formula. You should note that thing. Fluorine, similarly, let's go to next slide. we are moving to next slide. Let's erase this first. Now sodium outermost has one electron, so it should lose one electron to be stable, so they lose electron. Similarly, magnesium outermost, it has two electrons, so its valence is also 2, it has to lose 2 electrons. Ammonium, it has outermost 3 electrons, so it should lose 3 electrons and it will come back to octet state, and its valence is 3. Similarly, you know 1 to y valence is 1 2 3. It should go to octet state, and if it lose this electrons, it has outermost 8 8 8. Similarly, in case of silicones, there are 4 electrons, and there are two probabilities. One, either it can gain 4 electron or it can lose electron. So generally this doesn't happen. So they form a covalent bond. They form a chemical reaction by sharing of electrons, which we will learn in higher class. Just you know that its balance is 4. Similar in case of phosphorus, sulfur, and chlorine, it has 5, 6, and 7. It should lose. It should gain 3 electrons, it should gain 2 electrons, it should gain 1 electrons. And so they are reactive. Why chlorine balance is 1? Because it has to gain 1 electron, so it is in octet state, and it also should gain 2 electrons, so it will also be in octet state. Phosphorus also should gain 3 electrons and it will be in octet state. And similarly, argon outermost is 8, so it is completely full, fully filled, and so its valence is 0. So they are stable, they are non-reactive, they are not active atoms. Similar in case of potassium, its outermost has 1 electrons and it has 2. It should donate 1 electrons, it should donate 2 electrons. It should lose 1 and 2 electrons, so they are stable. And one main things I want to introduce to you all from here is those with lose electrons. Similarly here case of here 3, and similarly here 2. If they lose electrons, then they are called metals. Those which gains electrons are called non-metals. For example, 5, 6, 7, and they are called non-metals. This 8 is also, argon is also non-metal. Generally, which fulfilled or which gain electrons, which lose electrons are called metals. And there comes at the first of the chemical reaction. I will explain it all in next slides. Now here comes some important questions from this chapter. Why sodium is reactive? And now you can say, well, sodium is active because it has 1 electron in the outermost shell. So every atoms are it wants to be stable, so it has to lose 1 electron in order to be stable. That's why sodium is active. Why neon is stable? As you know from previous slide that neon has 8 electron in the outermost shell, so it is already stable. Its valence is also 0. So neon is stable because it follows the octet states. Why helium doesn't take part in chemical reaction? Because it is stable, because it has 2 electrons in the outermost shell, which it is stable by duplet states. Why chlorine is reactive? Chlorine has 7 electrons in the outermost shell. It should gain 1 electrons to be stable. And so chlorine is reactive, or you might say chlorine is active. Now here comes the new topic, molecular formula. Here is the word written: the symbolic representations of a molecules upon elements or of a compound is called molecular formula. If you represent elements or compound in terms of symbol, then it is called molecular formula. Simple definition is the symbolic representations of molecules, or you can say elements. Now moving to next slide. Additional information, try to note this in your copy, and here it comes. If there comes a D in the name of elements, think the corresponding element. For example, those who gain electrons, yeah, which are non-metals, which has valency 6, 7, sorry, not valency, outermost electron 6, 7, 5. Then we don't say chlorine, we say chloride. Chloride means it is saying Cl, its valence is, sorry, 1, it should be 1 over here. And second, sulphide sulfur, its valence is 2. Fluoride Fluorine, its valence is 1. And nitride, it means you should know nitrogen, its valence is 3. Similarly, if somebody says oxide, you can think about they are saying oxygen, whose valence is 2. So make this valence 1. I don't have pen right now, so I can change it, make it 1. Coming to the next slide, now see here, hydrogen chloride. Hydrogen chloride is written here. Hydrogen means H symbol. You are mentioning the symbol because we are writing the molecular formula, and the chloride means Cl. Both has valence 1 1, so cancel this 1 and 1. You are getting HCl. Similarly, sodium chloride. Sodium symbol is Na, and the chloride symbol is Cl. And you should know the valency, because I have been saying that you should know the element 1 to 20. You should know the electronic configuration, and knowing the valency, it will if you subtract with the 8, or just if you place the outermost electron, you will know the valency. I have talked detail in the web slides. Here 1 1 and cancel it, NaCl. Similarly, carbon dioxide. Carbon means C, its valence is 4. Oxygen O, its valence is 2. Just crisscross cancel this. This will 2 times 2 means C2O4. So what you can cross this one and you can write CO2. Similarly, aluminum oxide, AlNO. Aluminum has valency 3, oxide has valency, just crisscross is valency. Ammonia is made up of nitrogen, hydrogen, 3 1, you just cross, you get this one. And magnesium chloride, Mg, valency 2, Cl2, just crisscross it. So you can quote this, and you can write your topic. We are going to learn today about molecular formula. The sum of weight of the atoms present in a molecule is called molecular formula. The sum of weights of the atoms. Now you are given water, H2O. You should know water means H2O. That is a symbol of molecular formula. We have written the symbolic form of water is H2O, because it consists of hydrogen, oxygen. So hydrogen, how here H2, you can write it by using molecular formula concept, 2 into H plus 1 into, and hydrogen has a mass 1 AMU, oxygen 16, we have learned in previous class, and 2 plus 16 18 AMU. Similarly, molecular weight of carbon dioxide, CO2, 1 into C plus 2 into O. It means that carbon has 1 atom of carbon and 2 atom of oxygen. So 1 into 12 and 2 into 16, you are getting this value. So molecular NaCl, just place this value 58 AME, you are getting this answer. Molecular weight of calcium carbonate, CaCO3, that is 1 into calcium plus 1 into carbon, and this 3 is only for oxygen. So 3 into O, oxygen, 1 into 40, 1 into 12, you are getting 100 AME as a molecular weight. And this question is also asked sometimes. We will get the questions, what are subatomic particles at the atomic molecular mass of calcium carbonate. You are getting just this much question from this chapter, but this chapter is quite important. You are learning a lots of things, reactions, and all the clear concept of reactions can be gained from this chapter. So taking a lots of class on this chapter. To be smart in molecular formula, you can solve till grade 9 or 10 syllabus 2. You should know these some of the radicals. You know the name of the elements and corresponding symbols and corresponding valency. Now you should memorize these things. Positive radicals, ammonium, NH4 symbol, which valence is 1. Ammonium, NH4. Negative radicals, it means positive comes at first and negative at the back. I can show you here. Generally, this hydrogen can lose or gain 1 electron, so it comes at first. Sodium generally lose electrons, this gain electrons, this comes at back. Similarly, aluminum, it's lose 3 electrons, it gains 2 electrons, so this losing comes first and gaining second. So losing of electrons are called positive charge, and gaining of electrons are called negative charge. From also we can understand. Let's come to the slides. Hydroxide, if you say hydroxide, you should say the symbol OH and valency 1. Now hydro means H, oxide, so OH. Remember in that way. Carbonate, CO3. I made mistake over here. CO3, you should write as CO3, and valence is 2. Bicarbonate, HCO3, so valence is 1. If they say bi, then you should add one hydrogen at this top. Similarly, sulphate, here is bisulphate. It should be SULPHAT sulphate, which is a simple wrong, and HSO4. So valency also decreases when you include the bi over here. Valency 2, valency 1, valency 2. This valency should be 1, is a mistake. Chlorate ClO3, valency 1. I don't have pen right now, so I could make this. Nitrate NO3, valency is 1. And note this is an exercise book because they are very important one. And now let's move to next slide. What is the molecular formula? Sodium carbonate. What is the molecular formula? Ammonium bicarbonate, ammonium oxide, hydroxide, hydrogen nitrate, and water. Wait, before this, thank you for listening. Thank you. Have a nice day.